Can everyone hear me okay? Okay, wonderful. Welcome to the conference that we're having today for FSH here in Ontario. My name is Carrie. I'm the Ontario Chapter Director for the FSH Society. And this is a big deal. We started planning this a year ago and we weren't sure how it would come together, and yet the room is filled and this is amazing. So a little bit about myself. My daughter was diagnosed several years ago and we knew nothing about FSHD, so it came as a bit of a surprise. And we started looking for, research and reading, and we knew no one and we hadn't connected with anyone. And so I reached out to the American Society and we started this Ontario chapter up here, so that primarily we can do stuff like this, meet others, share ideas, learn from the experts, and come together so that we don't feel alone, so that we know that there's others out there like us who are living their best life. So today should be fun. My hope is that everyone leaves here today having made a social connection, so use those quiet times or the lunch time to connect with someone else. That's my hope, and also that you have a few more tools in your toolbox when you leave here, as far as how you can help yourself move forward. A few housekeeping things I wanted to point out. Sharika, some of you may have noticed, was out there welcoming people, and she was in the parking lot. She's going to be sitting over there in that corner, and she's a PSW and a nurse who's here today to help anyone with anything that they need to be comfortable. So if you need help getting a straw in a water bottle, or help in the bathroom, help eating, anything at all, just let Sharika know. She said she has eagle eyes, so she will keep her eyes on everyone, so you can just look her way. You could wave at her and she'll come over. You can also send someone else from your table to go and track her down, okay? Also, our bathrooms are just out there. If you haven't found them yet, there's an accessible bathroom. Men's is on the right, women's is just again across the hall. We'll be having lunch today. Oh, and we are recording. So thanks to this little owl up front, this is going to be recorded and then shared with other people in the chapter, so that those that weren't able to come here today can still get all the information. I think that was it. So yeah, I hope everyone really enjoys today. And next up is Neil Camarda from the FSHD Foundation.
Thank you very much. Thank you, Claire. Howdy, everybody.
Howdy.
Calgary, you can get away with that, Just, if you're any more excited, I might just do a yeehaw anytime here now, but no, I won't do any backflips, not until I get some therapies into here. But thanks for coming. Look at all the faces and all the people here, and I know that's a lot of heavy lifting to get, and a lot of organization to get people to come out, and really much appreciate it. We got to, this is such an interesting time for our disease, because 10 years ago, we would have been talking about therapies, and here we are. Some people are already on the therapies. And so we have, and today we also have in the room a couple of companies that are, have therapies or that are in clinic right now, but maybe coming into clinic. So to do with stopping the disease and getting our muscles back too. There's even a secret company in the room today. They may not expose themselves, or they just want to see how it's going here. So it's an interesting time. I shouldn't have said expose themselves, not in that way. Yeah, we'll see how it goes. We'll see how it plays here today, right? So before I forget, I just want to make a special shout out to Ann Harlan. Where did Ann end up? Is she still in here? Anyway, Ann Harlan. Oh, there's it, Ann. And so Ann got going on this FSHD organizational stuff network long before I came along, or FSHD Canada, a long time ago. And I ran into Ann and down in, of all places, Vegas. Don't ask why Ann and I are in Vegas, but what happens in Vegas stays there, that kind of thing. But anyway, so we were there, and I got, I came back from that deal, and man, we got to get something going here. So Ann has been my mentor through all of this. So thank you, Ann, and thanks. I'm sure you've helped to round up some of the folks that have come in here today. So I'm going to stop talking. I'm going to come back to FSH Canada a little bit later on, I'll talk about what we're up to, but we're punching our weight. We're punching our weight globally. We're mixed up with a lot of stuff, the research, the therapies, and some other stuff too. So I'll come back to that towards the end of the day. Towards the end of the day, when you're all tired, I'll be the last guy to stand up. I might do a yeehaw or something like that time, but I'm gonna hold back right now. So I'm gonna hand it over to Beth. Now Beth's got a tough job. She's got a really long agenda. So everybody's got 5-10 minutes, so she's gonna have to ride herd on everybody. So over to you, including me. Over to you, Beth.
Yeah,
Here we
let's
go.
get on, let's go. Thank you, Neil.
Yes, I am the timekeeper, so all speakers out there, if I start doing this from the back of the room, it's time to wrap it up, okay? And we talked about that last night. So again, welcome everyone on behalf of the FSHD Society and the FSHD Canada Foundation and from the Ontario chapter. Welcome to the Ontario FSHD 360 Regional Educational Conference. For those of you that don't know me, I know most of you, but not all of you. My name is Beth Johnston. I'm the Chief of Volunteer Leadership for the FSHD Society. And my family is also affected by FSHD. So shout out to my husband in the back of the room there. It's also his birthday today, so embarrass him really badly and sing a little happy birthday message when we hang you up later. Thanks to Neil Camarda and the FSHD Canada Foundation for making this possible today. I also want to thank our committed volunteer planning committee. Carrie said we started this a year ago, and we did. We met monthly. We reached out to people. We reached out to speakers. We put an agenda together. So these are the people that put this together for you today. Carrie Wilkinson, Jeannie LaRoque in the back of the room, Robin and Teresa Brown over here, yay, Scott Sawa, who couldn't be here today, Dr. Hans Lockmuller, where did you end up, Hans? Yes, he helped put it together, and my colleagues who could not be with us today, Jim Kinashita and Ashley Ferreira. So thank you guys for getting this done. The lights are low because it's just really hard to see this screen, so just don't fall asleep on me, please, because I can't see everybody. But thank you to everyone for being here today. I know, like Neil said, it's a Herculean effort to sometimes get up early in the morning and get to these events. So thank you for being here today. But by being here today, you are investing in yourself. You're taking important steps to becoming educated and empowered and to being your own best advocate when it comes to living with FSHD. And, which is really cool, today you are connecting with not only each other, but with outstanding providers and care teams that understand FSHD, world-leading researchers and experts, and clinical studies and clinical trials of FSHD therapies. So there's a lot going on in this room today, so thank you. All right. Just a quick overview of our organizations and the FSHD 360 program. So the mission of the FSHD Society is to accelerate the development of treatments and a cure for FSHD while empowering individuals affected by FSHD to live their best lives. The singular goal of the FSHD Canada Foundation is to help find a cure as soon as possible for Canadians who suffer with FSHD. And the vision of our FSHD 360 program is really to create a future where every individual affected by FSHD is informed, empowered, supported, living fully and confidently through access to knowledge, care, and a strong unified community. FSHD 360 envisions a world where patients, families, and healthcare professionals come together in partnership to transform the journey. So thanks for everyone for being here. Okay, and before we get started, a huge shout out to our generous sponsors and partners for the overall 360 conference program, Avidity Biosciences. And we do have a rep here, Henry Chinza. Where are you today? Henry's in the back of the room. Thank you, Avidity, for sponsoring the program. And our partner for the Canadian 360 conferences is the FSHD Canada Foundation. So had to do my due diligence and give shout outs to y'all.
There you go. That's close. Yeah.
All right, as you see, we have a packed agenda. It's full of great information. Our morning sessions are going to run to about 12:30. We'll have an hour break for lunch, and then we'll continue to our afternoon sessions that will start around 1:25, and we'll wrap it up around 3:30 this afternoon. I will just say, as Neil kind of mentioned, we are on a really limited time. We don't have a lot of time for Q&A after each speaker. So write your questions down, utilize the quiet time between speakers, use lunch, stay afterwards this afternoon. We have the space until 5.
to connect with the speakers and to personally meet anybody that you have questions for. Ryan Satellos, where are you? Okay, Ryan is with, don't tell me.
Satellos.
Oh, Satellos, that's not your last name. Ryan with Satellos. He actually has to leave a little bit early today, so if you're gonna grab him, he's the, very interesting program at Satellos, so grab him during lunch if you wanna have any questions for Ryan. Is that cool? Okay, thank you. All right, here's a list of all the speakers that are here today. Thank you guys for taking time out of your weekend and perhaps traveled quite a distance, Dr. Lockmuller, to be with us today. As you can see, we have some true slackers on this list. A lot of initials and MDs and PhDs and things like that, all these slackers. But honestly, the caliber of the speaker team is absolutely phenomenal. So thank you all for being here today. All right, moving on, I'd like to now introduce Dr. Hans Lockmuller. He is the professor of neurology at the University of Ottawa and the Ottawa Hospital Department of Medicine. He's a senior scientist at the Children's Hospital of Eastern Ontario, which CHEO is, if you've ever seen that acronym. And he's currently conducting several clinical trials and studies for FSHD. And he is an FSHD OG, as we say. And those of you who didn't grow up in the 80s, OG is an original gangster. So he is an FSHD OG. Thank you, Dr. Lockmuller, for being here today.
Welcome everyone, and thanks so much for inviting me and for the nice introduction. I actually didn't know the kind of thing, so I'll keep that in mind. All right, so I practice in Ottawa, both in the pediatric as well as in the adult hospital there. I'm originally from Germany, as some people recognize in my side dress. And I practiced both in Germany and also in the UK. And I have to say we've come a long way, as Neil introduced, from, well, when I started my career, so maybe you're guessing my age then, we didn't even know the exact gene that's causing FSH, and that had to be figured out first. And then once the gene was known and diagnosis was possible, then that was still not clear why that gene would actually cause disease. And that understanding then later helped to actually find targets, as we say, and develop therapies. So we've come a long way, even so, of course, many of you will say it took us a little too long to figure things out, and time is muscle. That's understood, but I think what's exciting, of course, is that you have input from all these different people, from the scientists in the labs that you shouldn't forget, because they are the ones who figured out all these really tricky things, to all the way to industry getting involved in developing these therapies. We couldn't do that. So, if you want to read a little bit more up on what we do, also on a national level, I might point out NMD4C. This is our national network for neuromuscular disease. That's co-sponsored by the Canadian Institute of Health Research and Muscular Dystrophy Canada, which is interested in FSHD for sure, as well as we have a website as well with that logo, my lab, and you can, for instance, find out what the trials are that we are currently running, because it's sort of a moving target, right? So it's changing all the time. So some of the stuff that I'm telling you today may be a little outdated in a month or two from now. So as a disclosure, I do work with many companies, not only in the FSH space, but of course in the FSH space. And the companies that are relevant to this talk are the ones that are highlighted in yellow. I'm not an employee of these companies. But of course, with aid these companies, we couldn't run the trials because they're all very expensive. So what I want to do in this sort of first short introductory talk, I don't want to tell you what FSH is clinically, because first of all, you probably know better than me. And secondly, we have real experts telling you more about it from an adult and a pediatric perspective right after me. I will just sort of ground the discussion in what are the genetic mechanisms and the cellular mechanisms that do cause FSH. And to start out with that, so the first thing that was found out was, of course, and that's known for a while, that in most patients with FSH, you have what we call autosomal dominant trait, meaning it's passed on from one generation to the next. This isn't always the case. Sometimes it starts in one person and we call it de novo. But as a rule of thumb, FSH, certainly FSHD type 1 is autosomal dominant. So as you probably know, everyone has 2 copies of each chromosome except for the X. That's a little different between women and men. But for all the other chromosomes, we have 2 copies. And so therefore, we also have 2 copies of chromosome 4. And it is sufficient to cause FSH if you have the genetic fault of one of your chromosome 4, okay? And therefore, if you have children, then you have the risk of about 50% to pass it on to your child. And that's the same for everyone. So what's happening there on chromosome 4, this is depicted here. So there is an interesting region right at the end of chromosome 4, and that the end we call the telomere, and then this region consists of structures that are repeated. So it's a repeat, and it doesn't actually have a lot of genes in it or information that's getting translated into proteins. So people were scratching their head for a long time. Why is it that a defect in this region would actually cause disease? Because nothing seems to be missing, really. And the defect that is causing FSH is actually, if a piece of that sort of long repeat region is missing, we call that a deletion. So that was a real puzzle for a long time. And there were even some people out there that had a deletion on that chromosome 4 telomeric region and did not get FSH, and that was even more puzzling. So very clever scientists, particularly Dr. van der Maro in the Netherlands, sort of figured out what's going on, basically. So what that long repeat basically is a switch. So it is a off switch in a way to a gene that's called the DUX4 gene, which itself is not deleted or not removed. So what does this switch do? So usually the DUX4 gene is not expressed, meaning it doesn't make protein in adult muscle. And the reason for that is because that switch makes sure it's silent, it's switched off. So if pieces of this switch of that repeat are removed, if it's deleted, then that means that the DUX4 gene becomes expressed and is getting active, and then it's doing something it shouldn't do. So that's the toxic effect of the DUX4 gene. So once that was understood, there is obviously now options to think about what can you do about it. Well, of course, first of all, flip the switch back or put in a new switch. And some of the therapies that are actually we're talking that we'll talk about later a bit. But on the other hand, now that we understand that actually the thing that is sort of causing the problem in the cell is the DUX4 gene, because it kicks off other genes that cause damage to the muscle fiber and causes inflammation, etc. Well, then let's go after that DUX4 gene itself, or the transcript of the DUX4 gene or the DUX4 protein or any of these downstream effects, right? So there's multiple options now that we can think of for therapy. And quite a few of them at these different sort of steps are now not only in animal testing, but in clinical testing, which is very exciting. Should also say that none of these therapies so far has made it to an approved licensed therapy anywhere. So we're not quite there yet, but certainly getting closer. We'll discuss these trials in more detail later on. But that is basically a cartoon that just says what I wanted to describe. Part of that switch function is actually what we call methylation. So DNA or genes are methylated, and that sort of tells them whether they should be active or not. So that's part of the switch function. So in FSHD, where that repeat is deleted, there is less methylation that sort of makes the gene, the DUX4 gene, more active. There's a second form of FSH where basically the same mechanism is at play. So there's more DUX4 expression because that switch isn't working well. It's not switched off. But in that case, the repeat is actually not deleted. There's another gene involved elsewhere on another chromosome that changes the methylation, and that's called FSHD2. FSHD2 is therefore based on a different gene. So in a way, it needs to be tested in a different way genetically, and the inheritance isn't quite as straightforward as for FSHD type 1. But some of the therapies that might work in FSHD type 1, because of the shared mechanism, should also work for FSHD type 2. Overall, if you look at all patients with FSHD, there's about only between 5 and 10% that have that second form. So anyway, and that's almost my sort of last data heavy slide in a way. So this is now how we're thinking about therapy based on that mechanism. So we can think about sort of putting that switch back into place, maybe methylating that region better, or even correcting the gene itself. We can think about fixing the RNA, the so-called antisense oligonucleotides, so siRNA, or we can go after the protein itself or any of these downstream effects. And potentially, because these are different kind of drugs and different modes of therapy, at some point you could even think of combinations of that if one alone wouldn't do the job. So, but there's some challenges that I should also mention. So, obviously, first of all, FSHD as compared to other sort of more common conditions, whether it's diabetes or strokes, etc., is relatively rare, and therefore it's more difficult not only to find the money to do all these trials, but also to find the right people who can participate in these trials, or even the doctors that understand the disease or want to run these trials. So that's the rare disease problems that people need to often come from far to participate in a study. They can't necessarily do this in their own hometown in the hospital. It's a slowly progressive disease. So you probably say, well, that's not entirely true. Something changed quite quickly for me at times. Overall, if you look at many people, it's not something that sort of kills you overnight. It's something that you actually need to follow and measure for an extended time to actually see whether a treatment makes a difference, right? So the trials tend to be fairly long. And there's a wide spectrum of clinical severity. So while there's some sort of correlation to how much of the switch is deleted, and the more of it is deleted, the shorter that repeat region is, the more severe usually is the condition. There's still, even within the same family, there's variability and variation and other factors that make them research more difficult, particularly if you want to figure out is a new treatment working or not. You would would ideally want to start with a group of people who are all pretty much the same to see that difference. We also, we've come some way with that, needed to figure out what do we actually measure to make sure we don't need to actually look at people for 5 years, because that's not something that a company would necessarily consider or would be viable. Something that is reliably measurable and changes quickly enough so that we can see the effect of the treatment. And there have been new outcome measures actually developed alongside these trials. One is, for instance, the so-called reachable workspace. So that was a test that was previously not known, or muscle MRI as one of the outcome measures to understand early on whether something is working in this trial space. And obviously, there's always also the hope that if there are changes in these pathways, in these molecules, that we could potentially figure out so-called biomarkers, meaning could we do a simple blood test that tells us whether somebody's getting better or getting worse, or whether a therapy works or not for this individual. So that's just for introduction, and we can, I think, take questions later, if that's okay. Thank you very much.